Hello everybody. So for today's lesson, we're going to be going over number sequences and arithmetic sequences. Some schools also call it linear sequences, but arithmetic is also kind of a way we say it, same thing. So yeah, let's get straight into it. So what we know about it from grade 10 is that if we have a number pattern, right, and let's say that whoa, I wasn't even touching this thing. If we have, let's say, a first term which is A, and then we want to continue with a certain difference. So we want to add it by D. So we plus it by D, and what are we going to get? We're going to get A plus D, right? But what if we're going to keep that difference the same over and over? We're going to add by D again, and we call that our constant difference. So that's going to be A plus D, which is also the set. Okay, let me rather not go into that now. And if we add another one, and so on and so forth, we are going to keep adding D constantly until we get to our final term, which this one now is just going to be A plus D plus D plus D, and then we can continue adding from there. So what are we saying? We're saying that A is our first term, A plus D is our second term, our third term is A plus D, and our fourth term is going to be A plus D plus D plus D. And then we keep adding and adding and adding. It just goes on. Okay. And now if we put that into mathematical terms, into like equation terms, this implies to us that term 1 is just going to be equal to A, right? Because it is our first term. And this implies to us that term 2 is going to be A plus D. And then term 3 is going to be equal to A plus D plus D. But notice that we can obviously take out, or we can just say that because D is adding by itself twice, then therefore it's going to be A plus 2D. Another way that you can actually do this is take D out as a common factor. D times 1, D times 1. We take out D as a common factor, we have 1 plus 1, and then therefore it's A plus 2D. But an easier way is just to look at it in the fact that it's D plus D, it's common terms, and the coefficients go out. So there's two ways that you can also look at it. And then this keeps going on all the way until, or let me rather do it like this, it goes on all the way until we get to the nth term. In this case, our nth term is where we replace whatever term we have. How do we get this nth term? We know it's going to be A plus something, right? But in terms of D as well. But in this case, remember, we didn't start with A plus D, meaning we didn't have the 1D for the first term. So therefore, we're actually going to say that the nth term is going to be where we subtract 1 by our n, if that makes sense. Because in the 2's place over here, we had 1D. But in the 1's place, we essentially had plus 0D, if that makes sense. So all we're going to do is multiply, say add by n minus 1, right? Which is indicating that when we have a value, we're going to subtract it by 1, and then we are going to get that value. Same over here. If we have 3 as n, then in this case here, it's going to be n minus 1, which is going to give us 2D, based from our derivation. And it's always going to multiply by D. So I know that was a little bit of a funny way to introduce arithmetic sequences, but I just gave you the derivation of the formula. So if you have a question in your examination that says derive Tn, and then there we go. You literally just did it. So I hope that helps you out a little bit. If you didn't understand, then I recommend just going over it again. Otherwise, let's get into actual application questions. Righty. So here we go. We are given a sequence. We are told that we have first 12, then 6, then 0, then negative 6. Now what are we going to do from here? Notice that the first term, which is term 1, is 12, term 2 is 6, term 3 is 0, and term 4 is negative 6. And it continues. So this indicates that it continues. Okay. So it continues on and on and on. Okay. But notice that we need to know, what is the first question? Find the nth term. And the nth term is essentially telling us we need to find out what is Tn. Because remember, what are we saying by the nth term? I know it looks completely alien to you if you're looking at it for the first time, but what is this? This is the first term. What is this? This is the second term, third term, fourth term, and this is the nth term. So therefore we need to find out Tn. And remember that Tn is equal to A plus n minus 1 into D, as we have derived it already. So we're going to call this A. We're going to answer A. So we need to find out what is A, what is n, and what is D. But the thing is, remember that we don't know what n is. We're calling it the nth term, so we're leaving n the same. So the only thing we are going to change is A and D. And we need to determine that. And what did we say A was equal to? We said A was equal to the first term. So therefore, A is equal to term 1, which is equal to 12, right? According to what we have here. But my question is, how do we find D? What did we do for the derivation here? We had to just add by D every single time. But how do we actually get D? Well, in this case, if we take the term, the second term, and we subtract it by the term before it, notice we'll always get the difference though. Because remember, we just want to find what's left. We take this value and we subtract it by what came before, and we get what's left, which was D. Let's show this, right? If I were to say that we have term 2 minus term 1, what is term 2 equal to? It's A plus D, right? A plus D, and we're minusing it by term 1, which is minus A. And then A minus A, they cancel, and we're left with D. I guess I'll write it here. What about term 3 and term 2? Term 3 minus term 2, remember what I said? It's the term minus the term before it. This is going to be T3 minus T2. It's going to be the case where it's going to be what? A plus 2D minus A plus D. And then what we're going to do over here, A plus 2D minus, we take the minus into the brackets and we have minus A minus D. We cancel out the A's, and 2D minus D is equal to D. And notice we will always get D. That is how you can prove that some sequence is arithmetic. So if they ask a question to prove that a sequence is arithmetic, you can give an explanation on why, but you can also use this to prove that the fact that if you get an answer of the difference and it stays constant throughout, then therefore it's arithmetic. If it's not constant throughout, it is not arithmetic. So meaning that the difference is essentially us saying that the nth term that we choose is subtracting by the term before it, which is n minus 1. Okay, n minus 1 just means the term before it. So therefore, what are we going to do? What do we note in this case over here? What is the term we're going to choose? Let's choose term 2 and then compare it to term 1. So let's say that n is equal to 2, in this case over here. So we're going to choose term 2 minus the term before it, which is term 1. And term 2 is equal to 6. And term 1 is equal to 12. So therefore the answer is negative 6. And if you were to do it with the other one, let's say term 3 minus term 2, it's just going to be 0 minus 6, which is equal to negative 6. Can you see that it's actually staying the same? So all you need to do is minus 6 each and every single time in order to get your constant difference and in order to keep the sequence true. Okay, so let's actually answer the question. I was just trying to broaden the understanding of all of this. Okay. So Tn is just equal to A, which we found was equal to 12. 12 plus n minus 1. Remember, we're not changing n, we're keeping it there. We want to find the nth term. Multiplied by the difference, which is 6, the constant difference. And then if we simplify it, we're going to have 12 plus, we can multiply the 6 into the bracket. So we have plus 6n minus 6. And if we simplify further, it's 12 minus 6, which is equal to 6. So we have 6n minus 6, plus 6. Okay, and there we go. We found Tn. For the next question, we need to determine the 50th term. So what do we notice? We found the nth term. Remember that this is the nth term. So we need to find the 50th term. So what is that telling us? That B is when we find T50. And what did we just do? We replaced n with 50, meaning in our equation, because we replaced n by 50, we'll do the same thing on the other side. So therefore, 6 multiplied by 50 plus 6. And then we know that 6 multiplied by 50 is just going to be equal to 300 plus 6, which is 306. My question to you is, can you point out a mistake that I've made? The mistake that I have made was the fact that I didn't take the negative into the 6. So if it was a case where you accidentally didn't take a negative in here, you would get a completely different answer. So what you need to take note of is that this is incorrect. And then this should also be incorrect. So if we take the negative 6 into this thing, right? So we have 12 plus, and then, 12 minus 6n. And then take that will be positive 6. Then therefore we'll have negative 6n, and then 12 plus 6, which is just equal to positive 18. So this is our nth term. So those who are screaming into the screen, I am sorry about that. So which means this is wrong. So we're going to have negative 6 into 50 plus 18 from here. And notice now, this is still correct, by the way. This whole thing that I've done here was still correct. It's just the fact that I want you to see that mistakes could be easily made. And I need you to always double check your answers for this one over here. Right, so negative 6 times 50 is obviously equal to negative 300, and we say plus 18, and this is just equal to negative 282, because we are adding 18 to the negative value over here. So this is going to be our T50. So therefore T50, the 50th term, or we could say over here, therefore the 50th term is negative 282. So that's the answer. Okay, I'm done with all this nonsense games over here. Okay, I swear. So number C, it says which term of the sequence is equal to 198? Okay, what is that trying to tell us? It is trying to say when we have a part of the sequence here, let's say, what was it? Negative 198, right? Negative 198. What is the term actually going to be? What is our n value going to be, right? Because we need to find out the nth term for this specific one over here. Okay, we need to find out the term, and the term is represented by n. So we need to solve for n in this case over here, meaning we need to use the nth term equation that we've made for ourselves, and then let it be equal to negative 198. So number C is going to be the fact that we have the Tn must be equal to 198. And this tells us that negative 198 is equal to negative 6 plus, negative 6n plus 18. Was that our equation? Yes. And then from here, we just solve for n. So we are going to take the 18 over, and then what are we going to have? We're going to have negative 198 minus 18, which should be negative 216. And then from here, this is equal to negative 6n. And then all we need to do is divide both sides by negative 6. So divide by negative 6, then we should be able to get n is equal to 36. Okay, so therefore the answer will be negative 198 is the 36th term. You can also say of the sequence. Okay, you probably thought we were done, but we're not done. I need to go over the more of the types of questions you probably expect from tests even. So in a linear sequence, the third term is negative 2 and the 10th term is 19. Determine an expression for the nth term of the sequence. So we basically just need to find out what is Tn equal to, like for the specific sequence that they're describing. But the only information we're given is the third term is negative 2, so T3 is equal to negative 2. And we are told that T10, which is the 10th term, is going to be 19. But my question to you is, in general, Tn, we know in general that Tn is equal to A plus n minus 1 into D. So the only way we can really deal with this is if we plug in 3 equals n and 10 equals n. So therefore this implies to us that T3 is just going to be equal to A plus 3 minus 1 into D, which is just equal to, let me rather do that next to each other. This implies to us it's just going to be A plus 3 minus 1, which is just 2, so it's 2D. And then T10 is just equal to A plus 10 minus 1 into D, which is A plus 9D. Okay. So what do you notice? We know that T3 is equal to negative 2, and T3 is also equal to A plus 2D. So that is where we start. Negative 2 equals to A plus 2D. Okay, I'm going to just color code over here that we both know these two are the same. So this is term 3, this is also term 3. For the orange, we know this is term 10, and we know this is also term 10. Okay, so we let them equal to each other. And then we also know, I'm going to do a AND type of thing over here, and we are going to have what? 19 is equal to A plus 9D. Okay. And this just looks like a simultaneous equation question where we need to solve for A and D simultaneously. So therefore, let's just continue from here. We want to let A be the subject of the formula because it's easier. Okay, so in this case, A would just be equal to, when we take 2D over, it's just going to be negative 2 minus 2D. And then, when we want to let A be the subject of the formula here, we take the 9D over, therefore A is just equal to 19 minus 9D. And then we just let this be the first equation, so equation 1, and we number this equation 2. And what do? In our step here, we are going to equate 1 and 2. Okay? We are going to equate them together, meaning let them be equal to each other. So what are we doing? We are going to eliminate the A parameter so that we are only left with an equation in terms of D. So it's negative 2 minus 2D equals to 19 minus 9D. And then we just solve for D from here. So clearly we want to take the negative 9D over there. So therefore it's minus 2D plus 9D. And then we're going to have 19 plus 2. When we take the negative 2 over, it's going to be positive 2. Okay. And then from here, what are we going to have? Negative 2D plus 9D is just the same as 7D. And then we are going to have 19 plus 2, which is equal to 21. And then we just divide both sides by 7, and we get D is equal to 3. Okay, so do you notice from here, we now know what D is equal to. D is equal to 3, according to what we need to find. And we just need to solve for a. So a we can get from subbing back into either equation 1 or equation 2. It would be easier to sub into equation 1. So now we can say sub d equals to 3 into 1. Okay. So that from here, when a is equal, what is a going to be equal to when d is equal to 3? It's going to be minus 2 into 3. Okay, because we know that d is equal to 3 and negative 2 minus 2 times 3. And here that implies to us it's negative 2 minus 6, which is minus 8. So we know a is equal to negative 8. So this implies to us now that a is equal to negative 8 and d is equal to 3. So therefore, the Tn for this equation, for this expression over here, for this whole sequence that we have, is just going to be a, which is going to be negative 8, plus n minus 1 into 3. And if you want to simplify it further, you can say Tn is equal to negative 8 plus, it's going to be 3 multiplied into the whole bracket. So it's going to be 3n minus 3, and therefore you can also say that Tn is going to be equal to minus 8 minus 3 is just going to be minus 11. So therefore, the final answer could be 3n minus 11. And then we can also check this by substituting our term values that they gave us. If we plug in if we plug in 3 into n, we have to get negative 2. Okay? So let's just check. If we're checking, then let's check term 3. We know it's equal to negative 2, but let's prove it. 3 times 3, right, which we are checking, minus 11 is equal to 9 minus 11, which is equal to negative 2. So that would be correct for that one. Let's check for term 10. For term 10, it's 3 times 10 minus 11 is equal to what? 30 minus 11, and we know that's equal to 19. And is term 10 equal to 19? Yes, it is equal to 19. So therefore, it works out perfectly. Alrighty, so here is everyone's worst enemy. Given a linear sequence 2x plus 10, x plus 14, and x plus 8, and it continues, solve for x, find nth term. So first things first, right? It is not that bad. Remember, we need to solve for x. And how do we solve for x? They tell us it's a linear sequence, so therefore it's actually just adding by a constant difference every single time. So we need to solve for x using this information. And how do we know what is d equal to? Remember that d is equal to tn minus 1. And what does that imply to us? It implies to us that if we want to solve for d, if we say the second term, which is, okay, so this is term 1, this is term 2, and this is term 3, if we plug in the second term, we have to subtract it with the first term. If we plug in the third term, we have to subtract it with the second term. Does that make sense? So therefore, let's do it to the first two, because why not? We plug in n equals 2, then therefore we're going to have t2 minus t1, which obviously in this case the difference is just going to be equal to x plus 14 minus, and then 2x plus 10. But here's an issue, right? Let's first simplify it as much as possible. So x plus 14 minus 2x minus 10, because we're taking the negative in, and then d is just going to be equal to minus x, and then it's going to be 14 minus 10, which is just positive 4. So minus x plus 4. But the issue is this. We're not solving for x if we're doing it in this way. The way that we know how to solve for x is the fact that we know the difference stays constant, meaning if we say t2 minus t1, we know what that is, then therefore t3 minus t2 is going to be the exact same, because they both have the same difference. T3 minus T2 is equal to D, and T2 minus T1 is also equal to D. So therefore, from that as well, we can say that, okay, I'm going to put this in 1, and then we can also say that D is also equal to term 3 minus term 2. Okay. Therefore, D is just going to be equal to term 3. What is term 3 equal to? Term 3 is equal to x plus 8. And we're subtracting it by x plus 14, which is term 2. And then D is just equal to x plus 8. Take the negative in, it's minus x, and it's going to be minus 14. And therefore, what we notice, the x's cancel, and we have 8 minus 14, or minus 14 plus 8, which is just equal to minus 6. Alright. But here's the thing. We know what the difference is from here. Can you see that we literally just found our difference, but the question is not answered? We need to solve for x. Okay, so I'm gonna say over here that we know that since D is equal to D, for the case where we have T2 minus T1 equals to T3 minus T2, then therefore that tells us that we are going to have what? What is T2 minus T1? T2 minus T1 is equal to minus x plus 4. Minus x plus 4. And this is equal to T3 minus T2, which is equal to negative 6. So therefore, to solve for x, we let x be by itself. So negative x is equal to, take the 4 over, it's minus 4, which is minus 10. And then therefore, x is just equal to 10. So therefore, we just solved for x by using this information we have. And guess what? We just shown that D is also equal to negative 6 somehow. And it doesn't always work like this, but we got lucky. Now, what is the next question? The next question says find the nth term, meaning we need to solve for what? We need to say Tn is equal to a plus n minus 1 into D, where we need to know what a is equal to and D is equal to. We know that D is already equal to negative 6. Okay. And we know that A is equal to, what is A equal to? The first term, and the first term is 2x plus 10. But because we know what x is equal to, this just implies to us that A is equal to 2 multiplied by x, which is 10, plus 10, which is 20 plus 10, which is 30. So therefore, A is equal to 30. So that's what we're going to say. Tn is equal to 30 plus n minus 1 multiplied by negative 6. And remember, there's a negative here. So Tn equals to 30. And then we take the negative 6 in. It's going to be minus 6n plus 6. And then therefore, Tn is just going to be equal to 30 plus 6, which is 36. So it's minus 6n plus 36. And this should be the final answer for the questions that we had.